So I think let's start. 8:06 हो गया है ना? Recording तो है. Today the first class for the rock mechanics, and in rock mechanics first we will study about the stress, strain. This is the basics for the rock mechanics. First is stress. What is stress? Unit of stress is pressure. ठीक है? What is the unit of stress? Pressure, Pascal. Pascal. So pressure क्या होता है? What is pressure? Pressure is force per unit area. Pressure is force per unit area.
Yes, sir.
So stress is denoted by sigma. Sigma equal to force per unit area. Okay. It is here. It is denoted by P. P is the force. What is the unit of force?
Newton.
Newton. What is the unit of area?
Meter square.
Meter square.
Yes, sir.
Yes, Newton per meter square is the stress. How a stress is developed? When any rod is there, any, let's say rock or anything is there, and you are experiencing a force P.
Opposite.
Yeah, in opposite sides. Then there will be a stress generated on the. Then there will be a stress generated on the each specimen, means particle. The that stress is given by sigma is equal to force per unit area. ठीक है? Newton per meter square. Here it is given 1 kilopascal is equal to 10 to the power 3 Pascal. 1 megapascal is equal to 10 to the power 6 Pascal. 1 gigapascal is equal to 10 to the power 9 Pascal. In question, it will be given as 1 kilopascal, 1 megapascal. So you have to convert in Pascal. So this is the conversion for that.
सर एक मिनट रुकिएगा. हाँ ठीक है.
What is area?
ठीक है सर.
अच्छा ठीक है. What is area here? Area is the cross sectional area. Means cross sectional area. Yeah, this area. This area. ठीक है? Understand? Which area?
Yes, sir. Yes, sir.
This is the area, is the cross sectional area. Let's do this question. A rod of 10 meter into 10 millimeter cross sectional. Cross sectional area is given. This ये cross sectional area. This is given.
सर ये किसी को ज्वाइन होने में प्रॉब्लम हो रहा है. नाम नहीं पता मेरे को.
मोहित को हो रहा है, बट वो मैं बार-बार एडमिट कर रहा हूँ, बट हो नहीं पा रहा उसका. I don't know why. मैं तो एडमिट कर रहा हूँ, बट उसका ऐड नहीं हो रहा. आ जाएगा. So a rod is there. This is the rod, and its cross sectional area is given. This is the cross sectional area. ठीक है? This is 10 by 10. Is carrying an axial tensile load of 10 kilonewton. Means load force is given as 10 kilonewton.
Newton. Okay.
Find the stress sigma. So how you will find the stress here?
Sir, P upon A.
P upon A. तो P कितना है? P is given 10 kilo
10
Newton.
kilo.
10 means 10 into 10 to the power 3 Newton.
10.
And what is the area here? Cross sectional area.
10 mm into 10 mm. 10 by 10, 100 mm square.
It should be in millimeter square. Try to do in meter square
Yes, sir.
for the
Yes,
SI
sir.
unit. Achha, what is the area?
0.1 meter square.
10 into 10 into 10 to the power minus 6 meter square. ये होगा? How 10
Yes,
to the power
sir.
minus 6 came? Because 1 millimeter is equal to 10 to the power minus 3 meter.
1000.
10 to the power minus 3 meter. So 1 millimeter square is equal to 10 to the power minus 6 meter square. So that's why area is equal to 10 into 10 into 10 to the power minus 6.
100 into 10 to the power 6
Minus
meters.
6. So what will be the answer? 10 10 कट गया यहाँ 100 into 10 to the power 6 पास्कल. So 10 to the power 6 पास्कल को हम क्या बोल सकते हैं? 10 to the power 6 can be also called as megapascal. Means 100 megapascal. 100 megapascal. Is it clear how to find the stress?
Yes, sir.
Yes, sir.
Only just divide force by area and also remember the unit of both sides. There are three types of stress. There are three types of stress. One is compressive stress, shear stress, and third one is tensile
Tensile.
stress. ठीक है? Compressive stress. From the name, you can see that compressive stress means compressing any object. Means you are compressing it. So what should be the direction of force for compression? What in compression the length will decrease, means whatever the length of this will tends to decrease, means force will be in this direction, it will compress. This is called compressive stress. What is compressive stress? Tell me. Which one is compressive and which one is tensile?
First one is compressive. Firstly,
First वाला compressive होगा और second
Yes,
वाला
it will be
tensile.
compressive and it will be tensile. So in compressive the length will tends to decrease. In tensile length tends to increase. ठीक है? And what is And what is in shear stress? You can see from the diagram, shear stress is not in the cross-sectional
आवाज
direction.
कट रही है सर.
सर
Hello, आवाज कट रहा है क्या?
Yes sir, बहुत.
Okay, 1 minute. इसको थोड़ा खिड़की पास रख देते फोन को. राइट ना, कैसा है?
अभी ठीक है.
Shear stress, in shear stress, force is not directed in the cross-sectional area like in the tensile or compressive stress. It is directed normally on the body.
Yes.
Let's say it's a body, it's a rock, and the force is applied in this direction or in this direction. What this will cause? This will cause to rotate the body or shift the or break the specimen in this direction. This is called shear stress.
Yes sir.
Detailed theory is also given in the PDF. Shear stress acts parallel to the plane of intersect. Means this is the plane of intersect. This is the bisectional. This is the rod, and this is the plane of intersect, and the force is directed parallel to the line of intersect. This condition is called, in this condition, what type of a stress is generated? Shear stress. Shear stress is denoted by tau. Always remember, shear stress is denoted by tau, or other compressive and tensile stress is denoted by sigma. ठीक है?
ओके सर.
This is for the shear stress and this is for the tensile and compressive stress. And the formula is same. Average shear stress is equal to P by area. But mostly compressive and tensile strength are more important. Stress are more important. A strain. A strain is denoted by this symbol. And what is a strain? A strain means change in length.
The original length.
Change in length by original length. ठीक है? So if you are applying a stress, if you are applying a stress like tensile stress, force P, length of this will surely increase because you are extended in this direction, so length will increase. So whatever the length will increase, let's say total length increase is delta L, delta is the length increase, and initial length of the rod, initial length is L. So a strain means change in length by L. Means final length after compression, after applying the stress, minus initial length divided by initial length. This is called a strain. Do this question. A rod of 100 meter in original length means L naught is 100. Original length is given 100 mm. 1 minute कोई आया, ठीक है?
Hello.
A rod of 100 mm in original length means original length of the rod is given, that is 100 millimeter, and an actual tensile load of 10 kilonewton means force is 10 kilonewton is applied on the body. Final length of the rod is 100.1. L final is 100.1 mm. So the rod tensile strain is, how much will be the tensile strain? What is the formula for the strain?
Change in length upon it.
Change in length by original length. So what is the change in length?
0.1.
100.1 minus 100. Okay, this is the change in length. What is the initial length?
100.
100. And both are numerator and denominator, both are in mm. So no need to change it in meter. Okay.
Yes. Yes, sir.
What is the value? 0.1 divided by 100. It is 10 to the power minus 3 m. Sorry, it is dimensionless. 10 to the power minus 3. This is the strain developed. Always remember, a strain is dimensionless. कोई dimension नहीं होता, ठीक है?
सर किसमें डायमेंशन नहीं होता सर?
A strain.
अच्छा यस.
अच्छा, do a numerical. A rod is there and a force of 100 kilonewton is applied, and its cross-sectional area is 0.01 meter square. Find stress developed and strain when initial length L0 is 100 mm, final length after the stress is 100.5 mm. Do this. Give me the formula for the stress. क्या बताया था?
P upon
by
A.
area, sir.
P upon.
Yeah, P upon A or force upon area. So what is the force here?
100 into 10 to the power 3.
100 into 10 to the power 3 Newton. And what is the area?
So 0.01 meter.
0.01.
0.01. It is in meter square, so no need to change anything. This will be the stress. 10 to the power 2 to 4 7 Pascal. Okay. What will be the strain? What is the formula for the strain?
Change in length.
Change in length by original length.
Change in length by original length. What is the change in length?
Sir,
0.5.
0.5.
Okay, 0.5 by, and what is the original length?
100. 100.
This will be the strain, and it is
0.01.
denoted by this. Is it clear? Stress strain formula.
यस सर.
सर
सर
इसमें जैसे अपन स्ट्रेस जो फाइंड कर रहे हैं वो स्ट्रेन जो फाइंड कर रहे हैं उसमें अपन मीटर स्क्वायर ले रहे हैं, और स्ट्रेस में जैसे आपने 100 mm दे दिया, बार तो सेम है, तो क्या इसको 100 को कन्वर्ट करेंगे इस सिचुएशन में कि नहीं करेंगे?
No, because delta L and L both are in millimeter.
Yes sir.
So denominator and numerator same unit है, कट जाएगा. So that's why it is dimensionless. Net dimensionless हो जाएगा.
सर ये वाला समझ में नहीं आ रहा
कौन सा?
सर 10 की पावर 3 वाला सर 10 पावर 3 वाला सर ये कहाँ से है?
वो मैंने बताया था ना.
स्ट्रेस पूरा एक बार और बता दो ये वाला
कौन सा?
ये सर
स्ट्रेस
Okay.
ये सर F by A
ये
कहाँ
सर
से बता
किलो न्यूटन.
किलो न्यूटन मैंने स्टार्टिंग में बताया था. I have written in the first page.
यस सर
First page that 1 kilo Pascal is equal to 10 power 3 Pascal.
यस सर
1 megapascal to 10 power 6. वहाँ पे क्या दिया था? Here it was given as 1 kilo Newton. Kilo means 10 power 3.
यस सर
And mega,
Yes, sir, आगे
1 MPa mega means 10 power 6. Where if G
Yes.
and G, where agar mega Newton will be given, mega Newton, then it means 10 power 6 Newton. So convert it in SI unit, then after that solve it.
यस सर
तो अब any problem? स्ट्रेस आ गया. फोर्स पर यूनिट एरिया
yes,
ऊपर न्यूमरेटर में फोर्स करना है इन न्यूटन. फोर्स शुड बी इन न्यूटन एंड एरिया शुड बी इन मीटर स्क्वायर. एरिया क्या हो जाएगा? एरिया इज द क्रॉस सेक्शनल एरिया. लेंथ इनटू ब्रेथ. क्रॉस सेक्शनल एरिया L into B. One more numerical you want or this is enough?
लेट्स डू सर.
क्या?
करेंगे सर.
ओके और प्रैक्टिस करते चलो. Force applied on a body is 100 kilo Newton and cross sectional area, cross sectional dimension is given as E equal to 10 millimeter, B equal to 5 millimeter. Okay, and length is given as 50 mm. Sorry, 50, let's say it's 50 centimeter. 50 centimeter. ये L naught and L final. L final is given as 50.1 centimeter. ठीक है? Find a stress and a strain. लकी बताओ व्हाट विल बी द फोर्स. ऊपर में क्या हुआ न्यूमरेटर
100 किलो न्यूटन
100 किलो न्यूटन. 100 किलो को दिस इज किलो न्यूटन. दैट्स व्हाई यहाँ पे पावर क्या होगा 10 पावर 3. पावर विल बी 10 पावर 3 एंड डिनोमिनेटर
50 into 10 की power 6.
व्हाट विल बी द डिनोमिनेटर. व्हाट विल बी द एरिया
50 into
लेंथ इनटू ब्रेथ 5 इनटू
10 into 5.
10 into 5
Yeah, but it is in millimeter. Millimeter.
यस सर.
So if
power 6.
area in millimeter square को convert करेंगे in meter square, then it will be multiplied with 10 to the power minus 6. ठीक है? 10 to the power minus 6. So here, after converting in meter, you have to multiply with 10 to the power minus 6.
यस सर.
Force per unit area. Is it clear? If area is given in millimeter square, then after converting it in meter square, it will should be multiplied with 10 to the power minus 6.
सर 10 की पावर -6 सर कैसे सर इसमें तो
मिलीमीटर को मीटर स्क्वायर में चेंज किया।
मिलीमीटर।
Yes, sir. Yes.
1
अगर
मिलीमीटर
एरिया
इज इक्वल टू
mm स्क्वायर में हो तो
10 to the power minus 6, sorry 10 to the power
Yes.
-3 मीटर
-3
1 मिलीमीटर में।
Yes.
1
sir.
millimeter square means squaring both side is equal to 10 to the power minus 6 meter square.
Oh. Yes, sir. Thank you, sir. आगे।
तो ये 2 GPa हो जाएगा ना।
10 to the power 3 2 gigapascal, correct? 10 to the power minus 9, 10 to the power 9, sorry, 2 gigapascal, because it is 2 into 10 to the power 9. 10 to the power 9 can be written as giga. What will be the strain?
याद करना होगा।
अब ये तो तुम्हारा क्लास 4-5 में याद करना था।
चेंज इन
0.00
चेंज इन लेंथ ऑफ कॉर्नर,
चेंज इन
Change in
लेंथ
length
बाय
0.1 by 50
original
length.
length।
original
What
length.
what is the change in length?
0.1
0.1.
0.1
What
by
is the
50.
L? L is 50. This will be the strain. Strain is divided by
yes
this.
sir.
Okay. I think now it's clear, stress and strain.
Yes, sir.
Sure.
yes sir, yes sir।
It depends on your revision, whether you are doing revision or not. Acha, here in this case a strain is in negative. So what it denotes? If a strain is in negative, means tensile, means it is a stress is compressive. Compressive stress is there, means delta L means change in length is negative, means length is decreasing due to the stress. Now another type of strain is बोलो।
अगर पॉजिटिव हो तो टेंजाइल होगा।
Positive means tensile. Positive means tensile stress. Means delta L positive means delta L positive means final length is increasing.
टेंजाइल। Okay.
When it increases, when you apply pressure or force against, means in tensile direction. You are stretching anything. If you stretch anything, then it will increase in length.
Yes, sir.
Yeah. Another type of a strain is there, shear strain, that is denoted by gamma. When this type of a strain is applicable, when there is a force applied perpendicular to a element, means like perpendicular to this direction. What it does, let's say this is a 3D object. If you apply a force in this direction, so it will create a, so this point will be displaced to this point due to the force.
Yes.
And this point will be displaced to this point. So after the stress, what will be the new position? New position will be this after the stress. So whatever this length that is, whatever this length that it is displaced is called this delta, and L, whatever this length, total length L is, will give
सर
here a strain. हाँ बोलो बोलो
सर, जैसे इसमें शेयर स्ट्रेन में ये जो P फोर्स लग रहा है, ये जब दोनों डायरेक्शन से लगेगा तभी ये क्रिएट होगा ना?
नहीं, दोनों डायरेक्शन से लगेगा तो फिर तो होगा ही नहीं।
इधर नीचे पे टायर लगे तब
नहीं, दोनों डायरेक्शन से लगेगा।
जैसे यहाँ, हाँ हाँ,
like this is the 3D body, let's say
Any
मैं 3D
solid.
diagram बना रहा हूँ कुछ.
हाँ.
Let's say this is the rubber. जो rubber is there, your pencil box
हाँ
rubber,
हाँ.
rubber is there. What will happen if this side is, if you press this side, only this side, you press करोगे with a force P. If you press this, then this point will be displaced at this point,
Yes, sir.
and so this point, this will be the new position. Whatever this displacement delta will give the shear strain. Means displacement.
सर
हाँ बोलो.
मैं जैसे ना इस पॉइंट पे बोल रहा था, ये वाले पॉइंट पे.
यहाँ पर.
हाँ, यहाँ
यहाँ
पर जब देंगे तब ऐसा वो बनेगा. नहीं सर, नीचे पे, अपोजिट नीचे
यहाँ
पे,
पर.
जस्ट उसके.
यहाँ पर.
हाँ हाँ.
If you will give the force like that here, so ये भी displace होगा.
And one force
This
जहाँ आप
point
लगाए
will
हैं.
this point will be also displaced.
Yes sir.
In question वो दिया रहेगा for 3D type.
हाँ हाँ.
For 3D type, it will be given by delta x plus delta y plus delta z. Means
हाँ.
means
Yes, sir,
displacement
ये
in x direction, displacement in y direction, displacement in z direction. हाँ. So that 3D part we will see later. But right now,
yes.
that 3D part वो बाद में देखेंगे. But right now, for what is shear strain? For that, what is shear strain? वो क्या होता है? Shear strain is the displacement due to the tangential force at a point and divided by the length L. वो 3D पार्ट जो तुम बोल रहा है वो हम आगे देखेंगे जब यंग्स मॉडुलस वगैरह आएगा तब उसका भी फॉर्मूला है.
ठीक.
Where delta is the lateral displacement of the upper face. Is we are applying force at the upper face, that point will be displaced, and whatever the displacement, lateral displacement is there, will give the shear strain.